In this video, we're going to derive the expression for the max height of a projectile launched at a v initial degree where it lands at the same height as its launch. So when you launch this projectile, it's going to be at an angle. We can break this vector up into its horizontal component and its vertical component, since these motions are going to be independent of each other. So in this case, theta will equal to 60 degrees, and we want to find what our y max, which is going to be the symmetric point of our parabola. So v initial y is equal to v initial sine of your angle. In this case, that is going to be sine of 60 degrees. So when you're at the top, your vertical velocity, vy, is equal to 0, since you're in the transition state of crossing into moving in the upward direction into moving downward, which corresponds with that velocity time graph. Now, you can use the expression vy squared is equal to v initial y squared plus 2a delta y. When you're at your maximum height, you're going to have your vy is equal to 0. You have your acceleration equal to negative g, just like anywhere else, and your change in y displacement is equal to the h max. So then we can see here that this would cancel out equal to 0. In addition, we see that our v initial y, since we solve for that right here, our v initial is equal to this expression. We can actually substitute this into our equation here. Now we have v initial sine of 60 degrees plus 2, and we know we have g here and delta y. That is going to be your y max. It's important to note that the acceleration you plugged in was negative g, so we can write this as negative 2g y max, since acceleration is pointing in the downward direction. What we can do is add 2g y max to both sides. So this is equal to v initial sine 60 degrees squared. All you do now is we'll divide both sides by 2g, and you get that the maximum height that your projectile is going to reach is equal to this expression v initial sine 60 degrees squared divided by 2g. Now, we know when we're on our unit circle and we're at an angle of 60 degrees, we are going to have 1/2 root 3 over 2. Since we're examining our sine, we have that value. V initial squared, we can move that squared, and we have root 3 over 2 squared divided by 2 times your gravitational constant. Now, if you square the 3, that is going to get rid of that square number, and then for 2 we have 4. We have v initial squared over 2g. Now, this simplifies to 3 v initial squared over 8 times g. So that is how we get that expression for the maximum height that our projectile is going to reach if we launch it at angle theta. Now, in general, a formula you can write down is y max is equal to v initial squared sine squared theta divided by 2g for launch angle theta. Our maximum height only depends on the initial vertical component of the velocity, and at the top, the vertical velocity becomes 0, which is why we were able to derive this